Welcome to nuclear chemistry. We're going to take a look at what differentiates a nuclear reaction from a chemical reaction. So, we already know that chemical reactions are when we take atoms and molecules and we rearrange those atoms and molecules to form new substances, all right? And we learned in our thermodynamics unit that a small amount of energy is associated with those changes. The difference in a nuclear reaction is that we actually take atoms and break those atoms down to form completely new identifiable elements. Okay, this says atoms have a change in the number of protons or neutrons, so it can either create a different isotope, which is where you have the same number of protons but differing number of neutrons, or you can actually form a completely new element. So the the biggest difference here is that you're going to experience extremely large amounts of energy change, and the ones that are the most popular are fission and fusion. Okay, so we're going to break down fission and fusion right now. So as far as fission goes, it says a very heavy nucleus is going to split, and it's going to cause a chain reaction. So let me show you what we've got here. Basically, this is a neutron, and this is a really heavy nucleus. It's a heavy atom. This particular one is uranium, which has an atomic mass of 92. So we're talking 92 protons and a large number of neutrons as well. So here's what's going to take place. So let me back this up a little bit. All right, so what's going to happen is that this neutron is going to slide in and it's going to hit that heavy nucleus and it's going to separate it into two smaller nuclei, but it's also going to release these three neutrons as well. So once this split happens, now these nuclei are more stable, and now those three neutrons go and find three more heavy nuclei, and they're going to split those as well. So you can already see what's happening here. Back this up a little bit more again, okay? So these three neutrons that come off, now their job is to go out and find another nucleus, and it's going to split that, and then so you're going to end up with that chain reaction. It's going to show the chain reaction here in just a second. It splits and then finds more and finds more and finds more, and so that's what causes that uncontrollable chain reaction that we see in a nuclear reaction. So let's go ahead and see what the rest of the notes say about it. Okay, it says uncontrolled chain reactions will result in an explosion in the form of an atom bomb. However, we can control these chain reactions in the use of a nuclear power plant. This says the control chain reactions create energy that heats water and produces steam, and then the steam turns a turbine. Okay, the advantages is that there's not any air pollution, and there is a lot of energy per a given amount of a smaller amount of fuel. The bad part is that the plant has to be maintained. Okay, there is a risk of accidents like the what was it, the Fukushima plant in Japan that after the tsunami hit, and now they're dealing with all of that. And it can be difficult to dispose of nuclear waste. So let me show you real quickly what's happening here. You're going to have a reaction which takes place right here in the nuclear core. Now, we have these control rods in place. The control rods are there to absorb neutrons. Okay, when they absorb those neutrons, that's what's going to allow us to control the reaction. So either way, that nuclear reaction is going to take place. It releases a lot of energy, which heats up this water. The water then, once it's heated up, it turns into steam and goes through this steam line and then turns this generator. So that's what ends up giving us our energy. Fusion is a different situation. Fusion is where we're going to take two or more light nuclei and we are going to join them together. Okay, this is what's taking place in the sun. So here is an example of fusion. So we take these two light nuclei. Now these are going to come together in a fusion reaction, and it's going to make a helium atom and one neutron. And so what's going to the benefit of that is that it releases an incredible amount of energy. In fact, the amount of energy is so high, we don't even know how to control it. Okay, we don't have a way to control fusion reactions right now. Okay, it says an uncontrolled fusion of heavy hydrogen results in an explosion, which is what's used in the hydrogen bomb. So we do know how to work with fusion. We just don't know how to control it in order to get energy. So if one of y'all can come up with that idea, that would really help us out. A little bit more on fission. Just briefly, it says fission can also be called radioactive decay. It can release radiation, which can cause cancer and mutation. Okay, any element that is beyond number 83 on the periodic table, which is bismuth, makes it large and therefore unstable. Okay, so it's kind of like that nucleus is trying to hold on to so many protons and neutrons that it can't hang on to all of them. And so what happens is that it wants to let part of it go. And so that's going to be that radioactive decay, which we're going to talk about on the next video. But either way, that's when these large nuclei break down. That's called transmutation. We're going to take a look at that on the next video.